I'm kind of giving you the crash course on what is an inverse function, what is a composition of functions. So this is page 403, and it says it's important to understand inverse functions as we're studying logs or logarithmic functions, because log functions are the inverse of exponential. So if you don't know what an inverse is, we can't relate exponential to log. So a function is a relation, you might have learned this definition in Algebra 2, in which each x has only one y value. So your schedule for school, you can only have one class during block 1, and you can only have one class during block 2, right? Hope can't be in art and math at the same time. So she only has one of them in her schedule, but someone else might have the same schedule as Hope. So Sawyer could also go to art during block 2. But as long as Sawyer knows where he's going, so Sawyer is the x value, he's going to a particular class, like art. Hope is an x value, and Hope's going to a particular class. Hope can't be in two places at once, just like your x value can only have one output. X can't be here and here. So for it to be a function, I always think of like a student schedule. Each x has to know where it's going. The vertical line test tested back in Algebra 2 for a function. So the vertical line test is if a vertical line can only cross a graph once at any time, the graph is a function. So if a vertical line can only cross a graph once at any point in time, then the graph is a function. So an example of something that would pass the vertical line test is our friend the parabola. And the reason for that is I can draw anywhere on this line a vertical line, and I'll only hit the graph once with each of my vertical lines. Something that would fail the vertical line test might be something like a circle. So a circle is not a function because when I draw my vertical line, I just hit the graph twice at the same x value. So this might be like when x is -1, y is 2, and y is also -2 at the same time. So that fails the vertical line test. Here's what's new for us today. What is an inverse function? You're exchanging your input and output values. So x is becoming y and y is becoming x. That's all that's happening. So if a comma b is your original point, now your point is b comma a. So you're not making them negative. You're just flip-flopping them in the parentheses or on the graph. Here's something that is frustrating to me as a math teacher. I don't like this notation. I just taught you what a -1 power did, right? If I have a number like 3, what is 3 to the -1st power? 1/3. That's a reciprocal rule. This is function notation, and it doesn't mean what we just learned that it means. This just means F inverse. So if this is A comma B, this is now B comma A. So it has nothing to do with reciprocal. So I don't like that they stole this same -1 notation. I mean, you're never going to see a -2 or a -3 or a -4. Over here, I can do 3 to the -2nd power and I get 1 minus. This just means inverse. F to the -1st means inverse function. So don't confuse it with your exponent rules. And this is important. When we talk about domain and range, they just flip-flop. Because if you flip x and y, then you just flipped your domain and range. I think some of this stuff will make more sense when we start finding inverses. So I'm just kind of giving you a bunch of definitions to flip back and forth to, and then we'll actually show you how to find inverses. So a one-to-one function. If I go back up here to a function, each x could only have one y, right? For it to be a one-to-one function, now it starts out, it already is a function. So it already had to pass this test. Each x had one y. But it's a function in which each y has only one x. So now, like Sawyer and Hope, they both can't be in art class. So a one-to-one relationship, like only this X gets to go to this location and only this other X gets to go to this different location. Each X gets one Y and each Y only gets one X. So that's called a one-to-one function. That's going to be important for inverses. And then the horizontal line test. So same thing, if a horizontal line only crosses the graph once, it is 1, 2, 1. Should have left you a little bit more room. Sorry. So if a horizontal line only crosses your graph once, it's 1 to 1. So if I pass in this direction, the vertical line test, but I fail in this direction, I am a function, but I am not 1 to 1. Does that kind of make sense? So you can't get here unless you've already passed the first test. This has to be a function to even get to the horizontal line test. All right, so an example of a graph that would pass the horizontal line test might be something like a linear function, right? Because that already would pass the vertical line test. And now see how when I draw my horizontals, I'm only touching it once in each location. Something that would fail the horizontal line test would be like the parabola. Because when I draw my horizontal, right, these were two different x values, but they are both sharing a y value of 1. Right? This might be like 4, 1 and negative 4, 1, and they can't share the same value. Here's the reason we care about it. This guy's inverse will not be a function. So the whole point is we're learning about inverses. We kind of care about these things because it's going to determine if I can have an inverse or if I can't have an inverse. So I'm not going to really test you on like this vocabulary. I'm really just going to test you on, can you find an inverse? But I feel like there's a lot of vocabulary here that you might not have seen or heard before. So at least you're exposed to, oh, the vertical line test exists and the horizontal line test exists. And then we learned this yesterday, and you were supposed to try these couple, but like Caden, you weren't here yesterday. So here's a crash course on what composition means. So this says inverse functions will always yield the result when composed. See how they're equal to x? All right, so here I'm showing that these are not inverse functions. So my first step, I'm going to plug g inside the f function. So see how the g function is 7x plus 3? I'm going to plug that into the original function right there for that x value. So I would get 3 times parentheses 7x plus 3. I just plugged it in for that x value, minus 7. Some of you yesterday weren't replacing the x. So x is getting completely replaced by 7x plus 3. So once we plugged it in, now we're going to simplify it. Distributive property, I would get 21x plus 9 right here. See how I distribute the 3? So I get 21x plus 9 minus 7. So that gives me 21x plus 2. That is not equal to x. So I don't have to go any further. If it didn't work in this direction, why bother doing this into this function? It already failed, right? I didn't get x. Down here, if it works in this direction, you also have to prove that it works in this direction too. So if it doesn't work, you could be done when it fails. But if it does work down here, you have to show f into g and g into f. So I'll do the first one, and then you try proving the second one. So I'm going to do f of g first. So kind of the same direction. I'm going to take this guy over here, and I'm going to replace that x in that first problem. So I would have 1/2. I'm going to get rid of that x and plug this whole parenthesis in, 2x minus 20. And then this plus 10 was part of the original problem. I want to see if that stuff cancels out.
And it looks like it does. This just gives me x. This gives me half of negative 20, would be negative 10. And I'm adding 10. So see how that gives me x? So I've halfway proven that these two functions are inverses. I know that this undoes this guy. So now you're going to plug this one in over here and show that the same things kind of cancel out. So you're going to try g of f of x. So see if now you can take the f stuff, so this whole thing over here, you're going to plug it in and replace this x. So follow the black arrow, replace that x, and see if you can get it. So you're doing composition of functions, which is not an easy algebra skill, right? It's kind of a learned algebra skill that seems kind of random right now. What about math and cowboy? Don't cowboys like need fire? So could fire be like an important thing that cowboys need? And math and fire have been invented from the origins of time? No. Yeah, math. I don't know. Fire. I don't know. No. I don't know. No, I think something that cowboy needs. Why do they need math? I don't know. The speed that their horse travels. Okay, so let's see what I get. I'm plugging in, I'm doing 2 times 1/2 x plus 10, and then I'm subtracting 20, right? I'm over here. So 2 times 1/2 is just 1, so I'd get x, and then 2 times 10 is 20, and I'm subtracting 20. So yet again, I get, they both canceled out, and I got an x each time. So if you had to justify if something is an inverse or not, are they inverses? This shows that they're not inverses, and this shows that they are inverses. I'm not going to have to do much proving that they're inverses, but it's just, why are they inverses? Why do they undo each other? So here are the strategies. So it's the strategies that you need to be able to use so that we can use exponential functions and log functions. The first one is finding an inverse by graphing. We already know how to graph exponential functions, right? An exponential function just looks like this. So if I can graph an exponent, I'm going to use this process to graph what a log looks like. I don't know what a log looks like yet. Here's a function that you know, though. You know how to graph a line, hopefully, y equals 2x plus 5. So let's graph that line first. What's my y-intercept? Y equals 2x plus 5. 5. 1, 2, 3, 4, 5. That's my y-intercept. And what's the slope of this line? How can I make my slope into a fraction? 2 over 1. Y equals mx plus b. So I'm going to go up 2 over 1, and I'm going to dot 2 points in this direction and 2 points in the other direction and kind of connect them like that. And now, how can I use that graph to graph the inverse? So it says, remember, a comma b, if that's a point on this graph, then all I have to do is switch the x and y value. B comma a will be on my inverse. So I need to record what are those actual coordinates. So I'm going to do that over on this left-hand column. This is the point, what, 2 comma 9. This is the point over 1 up 1, 2, 3, 4, 5, 6, 7. So 1 comma 7. This was the point 0 comma 5. Kind of making a table of values, right? X, I could just make a table of values. -1 looks like 3. And -2 comma 1. So I made a table of values. That's my purple line, right? This is f of x. how do I graph F inverse? So I'm just going to use a different color pen. You don't have to. If I switch the x and the y value, now I have the point 9, 2 and 7, 1 and 5, 0, 3, -1 and 1, -2. So I literally took the x column and made it the y column of my table, right? So this is F inverse. So I'm going to graph those blue points, and that is my inverse. So 9, 2, 1, 2, 3, 4, 5, 6, 7, 1, 5, 0, 3, -1, and 1, -2. This seems a little bit tedious, so it'd be nicer to have an algebraic way to find an inverse, but I didn't. So take a minute and graph the inverse. This is your inverse function because you switched your x with your y. That's your inverse. So we're going to use that to find our inverse for exponential in a few minutes. And it says, draw in the line y equals x to show that the two functions are mirror images or reflections of one another across the line y equals x. I don't know why the quotation got deleted on mirror images. Okay, so let me just jot it in a highlighter maybe. The line y equals x goes through the origin and has a slope of up 1 over 1. So see how if I use that as a mirror, if I fold this paper in half, my two lines would land on top of each other, right? If I fold it along the yellow line. So you just found an inverse by graphing. So that's one out of the two ways that we're going to find inverses. Can I flip it? Okay, now you're going to try one. Hold off on number 2, but on graph number 1, if you could graph the function, so y equals mx plus b, you don't need to dot in 5 points. Maybe just do 3 of the points, because any 2 points make a line anyway. So see if you can graph the original function, flip all the points, and graph the inverse function. Maybe we should make sure we're graphing the original function correctly. Where would I start? What would be my y-intercept? So I'm starting at -1. Does this hopefully seem familiar from unit 1? Okay, and then what's my slope? Down 4 over 1. It has a negative slope. 1, 2, 3, 4. And I'll just go 1, 2, 3, 4 in the other direction. So I've got those 3 points. You write down what those 3 points are, flip them, and graph the inverse. I'll give you a minute. So those are the 3 original points. You leave the negatives and you just flip-flop. So this would become +3, -1, and -1, 0, and -5, 1. So it's important you know your x's and your y's. So 3, -1, -1, 0, -1, 2, 3, 4, 5, 1. And then it says, make sure that your graph is a reflection over the line y equals x. And it is, because this blue arm would reflect on top of this purple arm like this. And then this guy down here, this would reflect on top of this. So even though they're crossed over, they still have a part that they're going to reflect onto. And it says, can you figure out what the equation is of that blue line? I want you to notice something. This had a slope of -4 over 1. What does this have a slope of? -1 over 4. So they have reciprocal slopes. So it's -1/4 x for the equation down on that other line. I think it's kind of hard for you to tell what the y-intercept is, but if I started, what was this one? -1, 0. Oh, I didn't draw it right through the right exact part of my y-axis. It should be right here. right? So the y-intercept actually goes through the point negative 1/4, right? Because this to this would be down 1/4 and over 1, and I hit the y-intercept. But we need a different strategy to figure out what the y-intercept is. So doing it from a graph doesn't always get you the right answer. But doing it algebraically would get you the exact answer in the exact equation that you're looking for. Okay, last one before lunch. Let's all draw in what a cubic function looks like, because this was a parent function from unit 1, so we don't want to forget what it looks like. It goes through 0, 0. 1 cubed is 1, and 2 cubed is positive 8. And if I go in the opposite direction, I get negative 1 and negative 8. Does that seem familiar, hopefully, from unit 1? So that's why I wanted you to know that that was the parent function. So we just said 2, 8, 1, 1, 0, 0, negative 1, and negative 2, negative 8. So flip those points and graph what your inverse would be. So 2, 8 just becomes 8, 2. 1, 1, and 0, 0, and negative 1, negative 1, those stay right on top of each other because they lie right on that line y equals x. So the only points you have to add are 8, 2, and negative 8, negative 2. So my purple dots are lying sideways, but they go through those same 3 points at the origin. Does anyone recognize this function? What is it? This one was cubic. This is cubic, x cubed. Its inverse is, what's the inverse of x cubed? If you were going to undo x cubed, what would you have to do? Not square root it, cube root it. So its inverse is the cube root graph. So cube root of x is the inverse of x cubed. Here's the cube, here's the cube root. So when it's going through again, the line y equals x. So after lunch, I'll show you algebraic. I know it's kind of boring. The other thing that you're going to have to do, you're going to have to graph a line or a curve and graph its inverse, and you're going to have to get the equation and find the inverse algebraically. So your first step is you can't switch x and y if you don't have a y. So your first step is if your equation has f of x, rewrite that as y equals so that you can see where your y value is. So I'm going to call this y equals 2x minus 3 divided by 4 instead. So I did step A. Now it says swap x and y. So I literally am only going to swap this y and this x. I don't get to move anything else. So I'm going to say x equals 2y minus 3 divided by 4. Everything else stays in the exact same spot. So that was swapping x and y. Now it says, now you need to solve this equation for y. So this is kind of the algebra tricky part. How am I going to get that y by itself? What's the first thing that I could bring to the other side of the equation? So I am currently dividing by 4. So can't I multiply both sides of the equation by 4 to get rid of the 4 that's in the denominator, right? We're thinking about inverses. What's the opposite of divide? Multiply. So now I have 4x equals 2y minus 3. What's the next thing that I can do? I'm trying to get y by itself. What would you do next to get y by itself? Yep, add 3 to the other side. These are not like terms, so 4x plus 3 equals 2y. And what's my last step to get y by itself? All right, so I'm kind of running out of room here. So I'm going to go through divide by 2 and rewrite this as y equals, because see how now y is by itself? So I really have 2x, because 4 divided by 2, and plus 3 halves, or plus 1.5. And they said if you wanted to, you could call this f inverse of x to show that you found the inverse function. So that should say f, and then this is like the little minus 1 of x equals 2x plus 3 over 2.
I'm not going to have you do this step right now, but if I plug this into the original function and vice versa, everything should cancel out and get x. So that's what it means to solve algebraically. Yep, and then let's do another one of those together. So we'll do another algebraic one together. All right. So it says, let's follow the steps that we just used to find inverses algebraically. So we'll do these together, and I'm going to give you, this is the end of these. So I'm going to give you a couple problems on the board, like if it was a quiz, what could you do it on your own before we're done here. So my first step is to switch x and y. I don't have a lot of room, so I'm going to start out by just writing a big y on top of the f of x, just so I don't have to rewrite the whole equation. So now I'm going to switch x and y. So I'm going to write it over here. X equals 3 times y plus 5 all over 2. So I switched x and y. So now I have to free up that y. What would you do first? So if you have a denominator, your first step is get rid of the denominator. So I'm going to multiply both sides of the equation by 2 so that my denominator is not there. So I have 2x. Now you have the option, you could distribute the 3, or you could leave the 3 outside the parenthesis. So either way, we'll get the same answer. What would be my next step? Let's just say I don't want to distribute it. Not subtract. I'm multiplying the whole quantity by 3. What's the opposite, the inverse of multiplying? So I'm going to divide through by 3 on both sides. So I have 2/3 x equals y plus 5. I'm almost there. What's my last step to get y by itself? Subtract 5 to the other side. And these are not like terms. So my final inverse, I'm going to just rewrite it, y equals. I had 2/3 x, and I had minus 5. So my inverse is the function y equals 2/3 x minus 5. And you can see a lot of opposites, right? I have a 2/3 here, but I have a 3/2 here. I have a minus 5 here, I have a plus 5 here. That's because when you plug them into each other, they all end up canceling each other out because they're inverse functions. I'm going to do number 2 with you because it's a little bit different of a function. And after we do the graphs down below, I'm going to have you do that kind of guided practice problem, maybe one more, just to make sure you've got how to do inverses. Can I move this one over? All right, so I don't see a y. My first step is to put y over the g of x. So y equals, this is gone, this is just y equals cube root of x minus 1. So I'm going to switch x and y. So x equals the cube root of y minus 1. So what's the next step at y by itself? What are you going to undo? Undo the root. How do you undo any root? If it was a square root, you would square both sides. If it's a cube root, right? So you're kind of reviewing in your head all of your rules of algebra. What's the inverse operation to addition? Subtraction. What's the inverse operation to multiplication? Division. What's the inverse operation to like a square root? X squared. Right? So all of these have inverse functions. I haven't done exponential yet because we don't have the inverse yet for exponential. So I'm going to cube both sides of the equation. So I have x cubed equals y minus 1. What's my last step to get y by itself? Add 1 to the other side. So x cubed plus 1. So my inverse function, if you notice a couple things, cube root and a cube, a minus on the inside of the function became a plus on the outside of the function. So if we plug them in, that's what we would get. We'd get x. All right, so here's kind of leading us into tomorrow, and then I'll have you try maybe a couple on your own just to see if you can get them. So it says graph the function, graph its inverse, right? So these are going to be my points like a comma b.
The inverse, I'm just going to do graphically and make those b comma a, switch them. And then we're going to graph the line y equals x to show their inverses. So 2 to the x. We learned this whole graph last unit, right? What are the key points on 2 to the x? Let's make our little table here. -2, -1, 0, 1, and 2. Fill in your table here for just 2 to the x first. See if you remember it from last week. Hopefully you do, because this unit's test involves some of our exponent items from last unit's test. And a lot of you got A's and B's on the last unit. So if I ask similar questions this unit, this small, it doesn't like go out. Why does it not work? Does anyone use a diffuser at their house? It's supposed to smell like orange. I like you smell orange over there. I think I got too small of a diffuser. What's 2 to the -2nd? Did you fill this in? Please tell me you remember. 2 to the -2nd is what? 1/4, then 1/2, right? Because you're flipping it, taking the reciprocal. Anything to the 0 power is 1, 2 to the 1st, and 2 squared. You have to know how to do 2 to the x. So 0, 1, 1, 2, 2, 4, 1/2 and 1/4 are really tiny. So that's my exponential function in blue right there. So the inverse function, which we're going to learn is the log function tomorrow, just takes those points and flip-flops them. So the inverse, we don't know its name yet. So the inverse takes 1/4 and puts that at -2. It takes 1/2 and puts that at -1. And 1, 0, and 2, 1, and 4, 2. So plot that inverse graph over here, and let's talk about what do they have in common? How are they inverses of each other? So 1/4, -2, 1/2, -1, 1, 2, and 4. And I want you to be careful when you're graphing it because we know something about this blue graph. What's the asymptote for the blue graph? Y equals 0, right? What's going to be the asymptote for the purple graph then? X equals 0, right? Because whatever it had before, we're flip-flopping x and y. So our log function actually looks like this. So isn't it flipped over the line y equals x? Right? The line y equals x goes right through the middle. So the purple graph is the graph of a log. So we're going to see that that's the parent function for a log. So exponential always goes through a y-intercept of 1, and a log always goes through an x-intercept of 1, right? Whatever this graph has the inverse. So wasn't this domain all real numbers? Now this range is all real numbers. This range was what? Y is always greater than 0. This domain is now x is greater than 0. So that's why you have to know the facts about exponential to figure out the facts for the log graph. All right, let's see if we can do one more. See if you can do graph number 2 on your own. So come up with your x, y values. I'm kind of out of space. X and y for 3tx. And then see if you can graph the inverse on the same axis. So graph 3 to the x first. It looks almost the same as what we got over here, slightly stretched. And this would be, kind of like a quiz question for next week. Because Monday we're going to spend, is that what I did? Monday we're reviewing for a quiz, right? Monday review, practice quiz, Tuesday. Wednesday and Thursday we're going to do log functions and practice. So. Oh, and then on Thursday, last time we had an early release. We kind of kept it on the down low, but are we going to try to? We should know the answer to that. Let's see. 3, this would be 1/9, right? Because I'm squaring it, flipping it, and 1/3, and then 1, 3, and 9, right? So it looks almost the same, but it's a little bit steeper than the one we just did. Because I get all the way up to 2, 9 on this one. 1, 3, 0, 1, 1/3, 1, 9. So here's my parent function of 3 to the x, and it has an asymptote at y equals 0. So when I flip all of these points, I'm going to get my log function right here. So I'm going to graph the flip-flop that. Maybe you can graph it in your head without flipping things, but I see it better if I see the coordinates. Like this is 1/3, -1, 1, 0, 3, 1, 9, 2. So if I need to see the points flip-flop to graph them correctly, you might need to see the points this way to graph them correctly. If you can do it in your head, do it in your head. So at 1/9, I'm at -2, -1, 0, 3, 1, and 9, 2 would look like this. So it's a lot steeper than the other one, and it's still a reflection over the line y equals x. So it would be important to know when you're looking at a graph, oh, so if I'm on the test and I'm looking at this graph, I know that's a log graph. But if I'm on the test and I'm looking at this graph, I know that's an exponential graph that's just been shifted down. So knowing the difference between, am I looking at a log or am I looking at an exponent is important. All right, here's the last one. See if you can do this problem. So it says you are going to try to take this function right here, y equals. You're going to try to graph that function and its inverse and solve algebraically by switching x and y. So if you can do the guided practice, this one problem, which will take you probably till the end, then you're good on this type of question, because this would be a quiz question. I give you a function, you graph it with a table, you graph the inverse with a table, and you switch x and y and solve for the function. So you're doing this function's inverse both ways, graphing it with a table. So you're going to try that last one. Met the competency for the day, so they say, right? Our little friends that aren't here, no, they didn't learn anything about inverses. Yeah.